So we can work outside in or inside out. Now typically it's easier to work inside out. So I'm going to work inside out. So I'm going to apply the power 3 here. Power 3 to power 2 is power 6 over 3. Or what you could say is that power 3 and root 3 undo each other and we're left with power 2. Okay, so that's going to be what we resolve when we simplify that anyways. Power y to the power 3, we have 125, y to the power 15, and then power 1/4. Okay, so 5 to the power 3 is actually 125. We have times 125, divide 125, so they all cancel out. We have x squared. Y to the power 3, so times by y 3 times, divide by y 15 times. So we're going to simplify that and say we have an extra 12 divides. 125's cancel out. Okay, so we have x to the power 2 root 4 over y to the power 12 root 4. We can simplify those ratios. And so we end up with x to the power 1 over 2, or square root of x, y to the power 12 over 4, which is just y cubed. So this ends up being the final answer here. So then the question becomes, well, the rule really was we can't multiply radicals with different indexes. However, we kind of can. And what we need to do then is really we just need a common index. Okay? Because we could actually change the ratio of this root and this power so that it matches this one when we change the ratio of this root and this power. So the long and short of it is we need a common index. Okay, and if we can get a common index, okay, that would work. Or in other words, if we were thinking it from the rational exponent perspective, we need a common denominator in the rational exponent. Now we need to understand that these actually represent the same thing. Okay, so we can do 2 to the power 1/3 times 5 to the power, what would that be, 1/5. We can change the indexes to be the same. So we end up with 2 to the power 5/15 times 5 to the power 3/15. Now that the indexes are the same, we can rewrite this as 2 to the power 5 times 5 to the power 3, and that's all over the index or the root of common root of 15, and that is one way we can multiply them together. Okay, so this, we could have kept this in radical form, so we could also express it this way. I'm just going to do this off to the side here. So I have 2 to the power cube root, and I have times 5 to the power 5th root. I can increase and decrease that by a factor of 5. So 15, 5. And that is, these are equivalent to each other. Here I can do increase that index by 3 and the power by 3, and these are equivalent to each other. They are the same radical. And what that does is it gives us a common index, or from the exponent perspective, it gives us a common denominator, which allows us to do this. Okay? So this is how this relates to exponent rules for multiplication and division. To multiply and divide exponents, or I should clarify this, multiply and divide rational exponents, we need a common denominator. That's kind of what we were alluding to up here. Okay, so this is important that we understand that these two things are connected. Getting a common index by changing the ratio of power to root, okay, like we did here, or getting a common denominator when we're adding these fractional exponents together. Okay, these are really the same thing. Okay, we are getting a common index. It allows us to group those radicals together in multiplication or division.